Okay, welcome. This is a very brief lesson on how to interpret output for bivariate correlation and multiple linear regression in SPSS. This is supposed to be a very simple, straightforward lesson, really just walking through the most basic types of analyses that can be performed in SPSS. There are a lot of things that I don't take into account that should be taken into account when you are completing analyses in SPSS. Okay, therefore this is just a simple, sort of straightforward approach to how you would go about conducting a bivariate correlation analysis, as well as a multiple regression analysis in SPSS, and in very basic interpretation of output. So what we have here are four variables. Okay, we have one dependent variable that we want to call the length of stay. And let's think about that as a length of stay in, I don't know, a psychiatric hospital, something like that. And let's think of this as a score on a psychiatric test. Let's say something like a test of depression, a test of sort of bad things. Okay. Whereas the higher scores are associated with lower levels of functioning. Therefore, we would want to see positive relationships between this variable, psych test, and then the dependent variable, length of stay. Okay, we would likely see that higher scores on a psychiatric test would be associated with higher levels, higher length of stay. Or a longer length of stay. These are also two other variables. One is substance abuse and the amount of stressors one person has in their life. Okay, so these aren't real data. These are just sort of mock data. So you can think about any type of problem or example related to these four variables. So let's quickly take a look as to how we would go about doing bivariate correlation. Bivariate, okay, that means two variables, one dependent variable and one independent variable, or one predictor variable. So let's put our dependent variable in there first, length of stay, and let's just look at scores on a psychiatric test. Okay, this should be checked. We want to take a look at Pearson's correlation coefficient. That's fine. We have two essentially continuous kind of variables that could range from 0 to theoretically infinity, but we don't have that here in length of stay nor in psych test, but they are two continuous variables, so we will use that. We don't need to necessarily look at the significant correlations because that's a pretty advanced issue, but let's, for our intents and purposes here, say that significant correlations reflect whether or not a correlation, let's say it reflects a very basic level of trust we can have in the correlation. Okay, so let's take a look at the options. Sure, let's take a look at our means and standard deviations for the heck of it, and then just click OK, see what we get here. We get a very small amount of output. We see that essentially the Pearson correlation coefficient is not related to the length of stay at all, so there's no relationship. Okay, 0.08 is very close to 0. All right, so we wouldn't have a correlation there. I'm sorry, we wouldn't have a significant correlation. I can't even say a significant correlation because essentially, let's take a look at what we're looking at here. We're looking at the strength of the relationship. A correlation looks at the strength of the relationship. So the question would be, is this a strong relationship? The answer obviously would be no. Let's, for the heck of it, see if we can find although this isn't the way you really go about doing analyses, let's see if we can find a correlation that has a stronger relationship with length of stay. So let's go back to analyze bivariate correlation. Let's get rid of psych test, and let's put in substance abuse and see what happens when we hit OK. It's down here we have a little bit stronger of a correlation than what we had up here. Okay, you'll notice we have let's see, 0.31 relationship between the two, whereas up here we had a 0.09 relationship. Okay, and this is not very strong. This is what you might call a weak relationship. And this is a little bit stronger, still relatively weak. All right, let's, for the heck of it, go back and take a look at the third variable there, which we called stress. Okay, let's do what we did again. Bivariate correlation. Get rid of get rid of substance abuse. And now let's go to stress and just hit OK. And now we have a 0.36, 0.37 relationship. It's close to a 0.40. So each one of these, we found a stronger relationship than in the prior. We had 0.311. And up here we had the 0.085. Okay, so we did certainly see a stronger relationship occur as we moved along. Okay, so why couldn't we sort of say, well, all of these are somewhat, or the last two at least, are somewhat associated with the outcome of length of stay? Well, that's because we analyze them separately. And what we need to do is sort of pit them up against each other like we would in a race. Okay, so that's where logistic regression comes in. First thing I want to do before I'm sorry, I got that wrong. Not logistic regression, just linear regression. Okay, basic linear regression with multiple predictors, or what you might call multiple regression. Okay, first thing I want to do is quickly look at a correlation coefficient. Not a correlation coefficient, a correlation graph, or what you might call a scatter plot. So let's quickly look at a very basic, what you might call a simple scatter plot. Let's define what we want on our y-axis, which would be our dependent variable, length of stay. And let's look at a stronger association, the one that we had for stress. Okay, let's just click OK and see what we get. We'll get a little scatter plot. Take a minute here. Okay, so boy, we see that the scatter's all over the place. But what I would do is I'd say, okay, it's not all over the chart. There's certain regions where and there's certain regions where it sort of clusters. So you might say it's kind of clustering around here. Okay, you don't see any up here, and you see in areas down here that are sort of also without these dots. So the relationship between low levels of one variable and like length of stay and low levels of another variable all the way up to high levels. Okay, low to high. Essentially, this scatter, any one of these dots, represents the relationship of one subject's score on this variable stress to their score on this variable length of stay. Okay, so any one of these dots represents that. All right, therefore, you can make some sense out of the correlation scatter plot here. Now, let's take a quick look at, let's take a look at what the scatter plot will look like in a relationship that is much weaker. Okay, so we'll still do a simple scatter, but we'll go back to our psych test rather than stress, because we had that at 0.085. So let's take a look at that scatter plot. And now we really sort of see data that are everywhere, all over this chart. Okay, we see a much wider, we don't see a whole lot of spaces where there aren't data. And we certainly don't see any kinds of patterns. Whereas up here, even though we had a weaker relationship, we saw a pattern. The pattern kind of looks like this. Most of our data points sit in here, which is sort of positive, which that's where we got that point, close to 0.40 relationship. Okay, so that's correlation for you. Now let's jump back to the question that we asked before, which is why wouldn't we just say, okay, well, now we can say something about how each one of these independent variables like psych test, stress, and substance predicts the length of stay. why couldn't we just stop here and say, well, each one of them are predicted or accounted for? Well, that's not the case, again, because we kind of have to put them up against each other. So we do that in, I'm going to close out this output. We do that with multiple correlation. Multiple correlation is also known as basic sort of linear regression. So let's jump over here to a linear regression. Okay, let's put length of stay in the dependent box. And just for lack of any better way of doing this, let's put all three of them into the independence box. Okay, let's look at some statistics that we want to look at. Let's take a look at the model fit statistic, perhaps some descriptive statistics as well. Okay, those look good. And let's pay attention to what to sort of interpret. Okay, what we want to interpret is we want to move down here and sort of take a look at the model summary. Okay, what we have is the linear relationship between all of our predictors and the outcome variable with this R. Okay, that's sort of the overall regression weight, what we have right here. Okay, so we want to pay attention to this R. Basically, this R square is just the 0.441 squared. And that is what's called your effect size, or what you should call your coefficient of determination. Okay, coefficient of determination. It tells you how much variance in the dependent variable can be described by or accounted for by the three predictors. Something else to pay attention to is your F ratio, because your F ratio is going to tell you about your significance, and this is the overall test. Okay, so we have a significant model based on this F ratio, so we want to look at the F, the significance. Okay, that's something important to look at as well. We also want to look at, notice how these are sort of similar to the the correlation coefficients that we got individually before. All right, notice how they're very similar. We knew that psych test was pretty low, and substance and stress were a little bit higher. Stress was close to 0.40, and substance was close to, I think it was like a 0.31, 0.32, something like that, if I'm not mistaken. Okay, so this essentially tells you about the relationship between each one of these alone and the dependent variable. Okay. The standardized coefficients over here, the unstandardized coefficients are thought of a lot like the correlation coefficients. I may have that backwards. These are your beta weights. I'm sort of blanking on the differences between the standardized and unstandardized coefficients. Let me pause this for just a moment. Okay, so I apologize about that. Just wanted to double check my thinking related to the B versus the beta here. Essentially, as I was saying, these are definitely the individual relationships. Okay, so that was definitely correct. The individual relationships between each one of these variables and the outcome, which is length of stay. The standardized beta coefficients are essentially how many changes, how much of a change in a standard deviation for this variable would be associated with a one standard deviation change in the outcome variable. Okay, so if there was a major change in length of stay, it would be associated with a very small change in psych test. These are also somewhat related, okay, the standardized and unstandardized coefficients. All right, so these are things that I would pay attention to. I also certainly want to pay attention to the significance level of each one of these, okay? Notice that we don't have any statistically significant values for the psych test variable, okay? Instead, what we have is a significant significant relationship between substance variable and the outcome, which is length of stay, and the stress variable, which is length of stay. Okay, and these significance values are based on the t value. Okay, so the t values are also important to look at. Essentially, when I'm looking at the model, I'm looking at the overall model summary, which again is the overall, what you might call this R is your multiple correlation coefficient. That's what your R should be thought of as, your multiple correlation coefficient. Your R square is how much variation in the outcome is explainable by the three predictors in this. Okay, again, that's called your coefficient of determination. All right, I'm looking at the significance of the overall model, so all three predictors were significant predictors of, they predicted quite a bit of variance, explained the model pretty well. And then I'm looking at the contribution of each individual predictor down here in this table, called your coefficients table. I'm paying attention to mostly these beta, B values, and then the betas are important as well, but not necessarily so important as taking a look at the significance to see which one of the variables perhaps were better than the other. Okay, so that is a very, very basic way to use SPSS to examine bivariate correlation as well as multiple correlation, also known as multiple regression. There's much more to this than just that.